Hello, today we're doing lesson 7.4, part 1. We're going to evaluate logarithms. Remember, we're going to do this without using a calculator. Okay, let's go ahead and get started. You know that 2 squared equals 4 and 2 cubed equals 8. However, for what value of x does 2 to the x equal 6? Mathematicians define this x value using a logarithm and write it as x equals log base 2 of 6. The definition of a logarithm can be generalized as follows. Let b and y be positive numbers with b not equal to 1. The logarithm of y with base b is denoted by log base b of y and is defined as follows. You need to know this. So take a look. We take the base of the log, we write it with this as its exponent, and we set it equal to this number. We're going to do that very, very, very often. You must know this, and you'll see what I'm talking about because we're going to get practice in a second. The expression log little b y is read as log base b of y. Okay, this definition tells you that the equations log base b of y equals x and b to the x equals y are equivalent. The first is in logarithmic form and the second is exponential form. So right now all we're going to do is rewrite them in exponential form. When I rewrite it, this becomes our base, this becomes our exponent, and we set it equal. Does that make sense? Is 2 cubed 8? Yes. Okay, over here, 4 to the 0 equals 1. Does that make sense? Yes. Anything to the 0 power is 1. 12 to the first equals 12. Again, that makes sense. I would like you to pause the video, and all I want you to do, there's no solving in this, is try rewriting this problem in exponential form. Okay, welcome back. Number 2 and 3 above illustrate 2 special logarithm values that you should learn to recognize. Let b be a positive real number such that b is not equal to 1. So when I see this, log base b of 1 equals 0, because b to the 0 equals 1. Log base b of b equals 1 because b to the first equals b. Makes sense, right? That's exactly what I had in example 2 and 3. Okay, now we're going to do some solving. There is going to be x in a certain spot. Right now, x is going to be our number. That is what it equals. These ones are pretty easy. So when I take a look, I'm first going to rewrite it. 7 to the first equals x. So what is x? 7. Okay, this one, 3 to the fourth equals x. This is again why we needed to know that note card, that information that we did in the last unit. So 3 to the fourth power is 81. Okay, 1/5 to the negative third equals x. We want to change this so we don't have a negative exponent, so that would be 5 cubed. So 5 cubed is 125. Pretty easy, right? When x is in this position, the problems are pretty easy. They do get a little bit more complicated, which we'll see in a minute. Go ahead, pause the video, and try the second you try on your own. Okay, now we're going to evaluate these. This is where it's a little tricky. We don't even have an equation. If there's no equation, that's what we're going to set it equal to, x. Go ahead, do that first. Now we're going to rewrite it in exponential form. So this becomes 5 to what power is going to give me 0.2. This one's a little tricky because you have to know what the fraction 0.2 is. That is 1/5. So we're going to say 5 to what power is going to be equal to 1/5. So what happens here? Our 5 moved on the bottom, so we definitely know our exponent has to be negative. And what 5 to what gives me 5? Just to the first. See if it makes sense. Does 5 to the negative 1 equal 1/5? Yes. Okay, let's try this problem. We're going to do 1/5 to the x equals 125. Okay, I went from a fraction to not a fraction. So again, I know my exponent has to be negative. 5 to what power is going to give me 125? So it has to be 3. Check to see if it makes sense. 1/5 to the negative third power equals 125? Yes. Okay, let's try this next one. 36 to what power is going to give me 6? Now this is different. I go from a bigger base to a smaller number. That means I definitely am going to have a fraction. What fraction? Well, what root do I take of 36 to give me 6? Just the square root. Check it. 36 to the 1/2 power, does that equal 6? Yes, because the square root of 36 is 6. So I know these are a little tricky and we're going to get a lot of practice with it, but go ahead, pause the video, and try the U-Try on your own. Okay, lastly, we're going to try some of these problems without a calculator. We're just going to do it by estimating. So a common logarithm is a logarithm with a base 10. It is denoted by log base 10 or simply by log. So if I don't see a base on my log, I know it's a base 10. So here, let's get started. I don't see a base, so I know it's a base 10. We're going to set it equal to x. So 10 to what power gives me 12? Obviously something very, very close to the first power, right? Because 10 to the first power is 10. If I do 10 squared, I get 100. So it's got to be very, very close. I should put little wavy signs because it's approximately 1. Okay, again, this has a base 10. So 10 to the 1.3 power equals x. Okay, well, 10 to the first is 10. 10 squared is 100. So it's got to be pretty close to the number 10. So all you're doing is estimating. You're just guessing and checking. Okay, questions, comments, or concerns, go ahead, write it at the bottom of the paper, and I'll see you tomorrow in class. And again, don't worry, we're going to get a lot of practice with these.